So now in this video series, I'm going to be focusing on taking a circuit in schematic form and building it on a breadboard. So here we have a really clear diagram on where you insert components, except for the LED, of course, it's polarized. It has to be inserted the right way, long lead there, short lead there. But otherwise, it's really easy to look at this board and be able to take this board and plug in components. A lot of times you see that in learning material. But this video series is going to be focusing on building the skills for just reading the schematic and being able to plug the components into the breadboard on your own. And I'm going to go slow with this because I know it's an area that a lot of people, kind of a sticking point for a lot of people, but it's not too bad. I'm going to go slow. It should be pretty easy to follow. So to begin with, let's take a look at the breadboard. So here you can clearly see that we have a whole bunch of holes here right next to this red line. Of course, there's a whole bunch of holes next to those holes, but they're next to the blue line. Every one of these holes here next to the red line is connected electrically. Okay, and you can think of this right here. These are all connected electrically all the way down to the bottom of the board. And then the blue wires, each hole next to the blue line, I should say, each hole next to the blue line is connected conductively. If you plug a wire in up here and then a wire down there, those two wires are connected within the board. So now, the purpose of this rail is for power. So usually up at top, but anywhere you want, you usually take a battery snap here if you're using a 9-volt battery, which I normally use. I don't have the battery on here to make sure we don't accidentally short circuit anything out. But in any case, you plug in the red wire into the red rail here and the black wire into the blue rail there. Or you could put it over there if you want to work your circuit across, positive to the left, negative to the right, however you want to do it. What I do, I plug the battery into one side, either side doesn't matter, and down here I have a wire connecting the red rail there to the red rail over there, and then a black wire connecting the blue rail there to the blue rail over there, so that I have power on both sides from the same battery. A lot of people don't like that. A lot of texts that I read in books and stuff, they want one side of the power source on one side and the other side on the other side. I don't like that, but whatever you prefer, whatever you like, go with that. So now we're going to take a look at these slots here in the middle of the board. So what this is, you'll see there's a ridge down the middle that separates from left to right, and then each one of these rows is separated from each other. So we have a conductive area with 5 slots here. If you plug something into 1A here, anything you plug into 1E will be connected to whatever you plugged into 1A, to any one of these spots actually. So there's a single conductive area here of 5 slots. And as I said, the left side and the right side are separated, so to connect the right side from the left side, you need a jumper wire or a component or something to make that connection. But in any case, this is what you should be visualizing in your head when you're building something, that this is one conductive area, and then this is a separate conductive area, and over here is also a separate conductive area. So now, before we move along, I don't usually use a 9-volt battery anymore. Now I've gone to this power supply here. So depending on how you wire this up, you can either have a 5-volt output or a 3.3-volt output, and that's on both sides here. You set this rail with this side and this rail with this side. So with this bench, or with this power supply, I do not use this these 2 jumper wires across here. The board automatically does that, and I only use these jumper wires with the 9-volt battery. But here's an alternative power source. This one, of course, doesn't go dead. You plug it into the wall. This is a 9-volt input. It came with this power supply, but it takes that 9 volts and either turns it into 5 volts or 3.3 volts, depending on how you set this little jumper there. So now we're going to come to the jumpers. So when you have a piece of wire, this is solid wire by the way, that is just bent. It's bent so that you can insert the two ends of the wire into there. These are called jumper cables. This wire that's flexible, this should have a stranded wire so that it can bend more in there, but there's little plugs at the end that are solid metal so that you can plug them into the board easy. These are called jumper wires. So obviously jumper wires are a lot more versatile. You can really jump it to like anywhere you want depending on its length. So I got a red one to the positive rail and then a black one to the negative rail here. But for me making videos and stuff, these wires get in the way and things like that. So for me, it looks a lot better using these jumper cables. Of course, what matters most is that you make the proper connections, not what you make them with. But in my case, I make videos, and so with me, it's far better and easier to see what's going on if I use jumper cables. So now, of course, it'd be nice to always use the red jumper for the red, the positive side of the power supply, and a black or blue jumper from the negative side. And the kit that I have, that I got these jumper from, they don't have black jumpers, just red and blue. And as you can see, they're really not that nice for plugging into the board. They jump way across the row. If I want to put negative here, I have to put it at an angle because it's too long. And so normally what I do have these orange ones to indicate more positive. It's kind of close to a red color. And then gray over here is kind of close to a blue color. And this is normally what I do. As you can see on the right side of the board, they fit in nicely. They don't fit in, the orange one doesn't even fit in on this side from positive to there. And the gray side sticks out a little more. But I normally work on the right side of the board because the jumpers I have, the jumper cables, orange and gray fit in nicely. And they fit in nicely on the right side. So again, it's whatever works, you know, you just need to make the connections. But for me especially, I need to try to make it look as nice as possible so that it's easy for people to see. But of course, by far the easiest way to actually wire something is with these jumper wires, because you can really move them anywhere from one connection to the other. They have a long reach and you can bend them around stuff. And so especially at the beginning, you might find it a lot more easier to use jumper wires. So now, when it comes to putting the components on the breadboard, at some point you'll be doing that from schematics. So I have a few different schematics here. It's the same circuit, but you may see it written from up to down, the positive voltage on top usually, and then negative ground at the bottom, and then the string of components. In this case they're in series. All it is a resistor and LED, as you can see there. Here you can see a battery schematic with the voltage written next to it, and again the path, but goes from positive side of the battery to the negative side, the ground. Or you may see it in this form, from left to right. And of course, as I said before, I use both a 5-volt power supply in my videos and a 9-volt battery in my videos. With the 5-volt power supply, you're going to want at least 220 ohms of resistance to protect things. With a 9-volt power supply, you're going to want at least 470 ohms of resistance to protect things. So now, as you can see in this diagram here, we have the positive side of the power supply connected to the resistor. So positive rail here, we used a jumper to connect to this side of the resistor. The resistor here is jumping the gap there, coming to an LED. So now the LED has two pins next to each other, and so they fit nicely from a top row to a bottom row. Long lead the anode here, you can see there, short lead cathode there, which goes to the negative side of the power supply, which we used a jumper there. The circuit here is kind of built around the LED. The LED has two leads right next to each other, and so it's the easiest component to make sure you put in two rows right next to each other, whereas the resistor and the jumpers can jump more of a gap. So here's a 3mm LED. I use these 3mm LEDs because I got 100 of them from China for $1. So this cost me a penny. They're pretty cheap, and you can put it in any two rows. Remember, the top is separated from the bottom. The long lead, the here, that's the anode side of the LED. Short lead is the cathode side. The anode side needs to be more positive. Generally with breadboards, you usually work positive down to negative. So generally you try to keep things towards the top of the board more positive. Not always. Sometimes it's easier to build a circuit with negative towards top for a particular component. But normally the positive side is up towards the top and the negative more towards the bottom. And now I took one of the blue wires out of the case here. I put all the wires away that I had out before, and as you can see, this one doesn't work that great, but this is a solid piece of wire on both ends. They plug into the breadboard easily. I just have to connect one side to the cathode of the LED and the other side to the blue side of the power rail there. So as you can see, this works. It makes a connection. Normally I would use a gray one. I'll show you that coming up, because that plugs in more easily, but ultimately it doesn't matter as long as you make the connections that you see on the schematic. And in this case, the cathode connects to the negative side of the power supply, and when we give this board power, this rail here will be connected to the negative part of the power supply. So we have a conductive path from the cathode to the negative side of the power supply. So now we're coming to the resistor. So looking at the schematic here, you see the resistor connects from to the anode of the LED and then to the positive side of the power supply. Now for 5 volts we need at least 220 ohms of resistance. For 9 volts we need at least 470 ohms. Usually with schematics, it's okay to go slightly higher than what they're showing. You may not even notice a difference in the circuit. That's pretty much going to be the case with this circuit. The LED is going to have about the same brightness at 5 volts with a 220 ohm or a 470 ohm resistor. So I got this 470 ohm resistor out of this bag. Now the resistors you usually get are 1/4 watt resistors, and so schematics are usually aware of that. Usually when they recommend a resistor of a certain value, they assume you're using 1/4 watt resistors because that's usually what you get. So in this case I have these beige resistors. You may get blue resistors. They work the same. I'm not going to go into detail on the difference, but in any case, I'm just going to jump the gap here from the anode side of the long lead of the LED over to this row over here. This resistor's jumping that gap. And now that we have the resistor on there, we need to connect this side of the resistor to the positive side of the power supply, which we have over there. And again, I'm going to use a red jumper for positive. I accidentally had it above the negative there, but just make that connection. And you want to double check after you plug them in that it is on the positive side there, this side to the resistor. It's really easy to accidentally put it in the wrong slot. Sometimes I put a power supply jumper into the wrong slot, and of course the circuit doesn't work. So every time you plug something in, you should double check that you actually put it in the right slot. It's easy to accidentally miss that. And when you're done, you plug in the power supply. So again, we had the board. I don't have that jumper at the bottom now, so I have to plug the battery into the right spot. Negative to the right here, and then positive to the left here. And then we plug in our battery to make sure that everything is working. And there you can see that the LED lit up. These breadboard power supplies are even easier. You got these 4 wires on each side. You plug them into the rails. They are marked on here, but positives on the left, negatives on the right for both of these. You just plug it in. I already have the power supply plugged into the wall. It's off because there's a switch. You hit the switch, now you see there's a power there. So even though we got 2 separate powers here, the board's not connected down there, you can run the positive from one side to the negative of the other side with no problems. And so now the next thing to take away, we built it based on this schematic, really moving from left to right, but if you notice these other 2 schematics, they show the same connections, and that's what's important. Schematics don't tell you how to build a circuit, they just tell you where the connections are. So here you can see the positive side of the power supply, in this case a battery schematic, goes to one side of the resistor. The other side of the resistor goes to the anode, the long lead of the LED, and then the short lead, the cathode of the LED, comes to the negative side of the power supply. That's commonly called ground. And here you can see it goes to the negative side. Again, the same thing with this one. Positive side of the power supply goes to one side of the resistor. Other side of the resistor goes to the long lead, the anode of the diode. Remember, LEDs are diodes. They're polarized. They have to be inserted the right way for them to conduct properly. The cathode goes to the negative rail. Often you'll see a ground symbol for the negative rail. Usually the negative rail is the ground when there's a ground symbol, but in any case, cathode to ground. So all 3 of these schematics tell you exactly the same thing, even though they're drawn in slightly different ways. And now down here, I'm going to build the circuit again, but I'm going to use the jumpers the way that they fit better in the board based on what I have. So I got the short one there, the positive, orange, the gray one there. And so again, the LED, the pins, normally it's best to just kind of keep them together. You can bend them out and stretch them across the board if you want, but I like to keep them together whenever possible. So we'll put the short lead here, the cathode, towards the negative side there. And we can move it over here if we want to, it doesn't matter. But now we're going to take the resistor, and that's going to make the connection between the anode and the positive side of the power supply there. And so just attach those 2 rows, and you can see it lights up because we already have the power on. Normally you do your wiring before you turn the power on, but in this case it was no big deal. But there you go. That's how you will more likely see this circuit when I do these projects. But again, the wiring doesn't matter as long as you make the right connections. That's what the schematic's for, is telling you the connections you need to make. And here's the same circuit with the jumper wires. Jumper wires have a lot more flexibility. Here you can see I kind of made it chaotically. So it's harder to tell what this circuit is doing looking at it because things are wired kind of goofy. But as you can see, when you arrange them a little better, it's easier to see. So even though what really matters is that you make the proper connections, still put some effort into making it look good, because the better it looks, the easier it is for people to see what your circuit is doing. So this looks a lot better, a little more organized. But as you can see, these wires makes a kind of a three-dimensional effect. It's a little harder to see than with these jumper cables that lay flat across here. But of course, when you're building your own circuits, do what's comfortable for you. But if you're going to be showing off your circuits, which I have to do, I make videos about almost every single circuit I ever make, then you know, you want to try to make it look as neat as possible. Alright, so now that's really the end of the video. There was one thing I didn't cover yet that I should. That's why I wrote these notes here, help make sure I didn't forget something. But these breadboards don't always make great connections. I did pretty good in this video today, had no problems. But sometimes it may not make a connection for whatever reason, and you may just have to kind of shift the angle that the wire goes in there. But if you have a circuit that doesn't work, try adjusting the wires and components and stuff, and if you shift it a little bit, all of a sudden your LED lights or whatever you got going on starts working normally. Just for some reason that slot didn't make a good connection. That seems to be more of a problem with cheap boards, I think. All I buy is cheap boards, so I really can't compare. But from what I heard, if you buy a more expensive board, a higher quality board, you're less likely to have connection problems.